I'm Alan Johnston, and I'm giving this presentation, the AMSAT CubeSatSim, a functional model of a CubeSat satellite for education. And I'm giving this presentation on behalf of my co-authors, Pat Kilroy, Jim McLaughlin, and David White. So a little bit about myself. I'm an associate teaching professor at Villanova University, which is a private university in the Philadelphia suburbs here in the United States. I'm also the Vice President for Educational Relations for AMSAT, the Radio Amateur Satellite Corporation, which I'll talk a little bit about later. I actually got my Bachelor's of Engineering degree at the University of Melbourne. I was born in Australia, but I've lived just about my whole life in the US. These letters next to our name are our amateur radio call signs, mine being KU2Y. When I was living in Australia, my call sign was the Australian VK3DQA. So some topics I'm going to talk about today. I'm going to introduce what CubeSats are and talk about AMSAT and amateur radio in space. And then I'll get into the details of the CubeSatSim, talk about ground station options, what we've done with it in universities and schools, and talk about payload sensors for it. You'll also be hearing about the CubeSatSim in Chris Mayner's presentation as well, so you can look forward to that as well. So a little bit about what CubeSats are, and apologies for those of you who are very familiar with CubeSats and their use in education. They are a nano satellite, and they get as small as 10 centimeters cubed, hence the cube part of their name. But they can also be bigger. They can be stacked in multiples. So a 3U1 is 30 centimeters tall and 10 centimeters wide. They are designed for low-cost educational launches. They're a standard. And they're, compared to most spacecraft, they're relatively inexpensive to build and test and launch as well. They typically go into low Earth orbit, and this excellent graphics from the Canadian Space Agency shows you the different orbits. They typically go into low Earth orbit, which is typically below the International Space Station, so 400 kilometers, sometimes a little bit higher. And a great thing about this is that they only stay in orbit for months, and then their orbit gradually decays and they burn up, and that way they do not contribute to space junk. So to get an idea of how CubeSats get into orbit, one way is as a secondary payload in a rocket. So this from ULA launcher shows how their rocket launches, and then has just on the edge of it there is a little CubeSat dispenser here, where after they've launched the main payload, whatever the big satellite is that's really paying them millions of dollars for this launch, then after that's successfully done, then they launch some small CubeSats. And as this graphic shows, the typical CubeSat, it's got solar panels, 10 centimeter cubed, 1.3 kilograms. So here's some detail about what that looks like. So you got this giant rocket, but the secondary payload is just this tiny little thing bolted onto the edge of it. And this is how the cost for launching CubeSats is much lower, because typically rockets might have to put ballast in, and this way they can do something useful with it. Here's some examples of some of the rockets that are used to launch CubeSats, and there's also a whole bunch of startups as well. This shows Electron here from Rocket Labs, which is really launching a lot of CubeSats these days. They launch from New Zealand, and they're about to start launching just near to me here in Virginia. But there's a whole bunch of startups whose business model is actually based around launching hundreds of CubeSats into orbit. Here's another way they can get into orbit is through the International Space Station, the ISS. And what happens is it gets loaded up with all the cargo for the periodic runs up to the ISS, and then it gets launched. This is a thing called a P-pod, and it has all the CubeSats launched into it, and one at a time springs basically shoot the satellites into orbit. So this image here from a NASA document about CubeSats shows you some of the steps involved, and you can see it takes it can take years in order to build and launch a CubeSat into space, and there's quite a lot of steps involved. The great thing about CubeSats are that they are a standard, and being a standard, it allows all different launchers to do them and to really minimize the cost of it. So a little bit about AMSAT, the Radio Amateur Satellite Corporation, which I'm a volunteer with. They were formed over 50 years ago, and they've been launching amateur radio satellites into space for that period of time. The very first one, Oscar 1, shown down here, which almost is cube-shaped, it was launched in 1959, so just a couple years after Sputnik. These days, AMSAT has been launching these Fox series of CubeSats here, and they've been very successful. So these CubeSats have amateur radio transponders in them, so they relay signals, so ham radio operators can talk to each other. I've done it myself. It's actually quite a lot of fun to make contact, across the country or across the ocean with other hams by talking to a tiny little box flying at 18,000 miles an hour across the sky. So another aspect that AMSAT is involved in, besides launching satellites, they were also a sponsor of ARIS, Amateur Radio on the International Space Station. And this is a group that organizes contacts, live ham radio contacts between school groups and children and astronauts on the ISS. So this picture here shows one in the past where an astronaut orbiting overhead answers questions from school kids, and it's a really inspiring event. There was one this year in Australia. I can't remember where it was, but maybe I'll remember for the question and answer. But anyway, it's really inspiring for the school kids to plan these events and see all the equipment that needs to get set up and learn about the ISS, and then get to actually talk to an astronaut and get their questions answered. It's a real life-changing experience for some of these school kids in getting them involved in STEM and in science and in space. Okay, so with that background, let's talk about the AMSAT CubeSatSim. So it's a functional model of a CubeSat, and instead of taking years to build and tens of thousands of dollars, it just takes a few weeks and a few $100s. It's based around a Raspberry Pi Zero, which is really popular Linux-based open source computer. It has a 3D printed frame, which you can print at schools and libraries, it's designed to look and feel and act like a real low Earth orbit satellite. So it has rechargeable batteries, and it has very low cost solar panels that when you put it in the sunlight, they charge the battery just like a real CubeSat. It also has a ham radio transmitter in it, and it transmits housekeeping telemetry on the amateur radio UHF band in a variety of different modulation schemes, and it can also transmit slow scan TV images. And if you put it in front of an LED lamp that acts like the sun and put it on a rotating table so that it spins, it basically generates very realistic looking telemetry with temperature and voltages and currents, which can then be analyzed and learned. So you can really learn an awful lot about space with the AMSAT CubeSatSim. So one other thing that we think it's really good for is to help solve this problem that unfortunately too many CubeSats just fail when they're deployed. They're infamously called flying bricks because we never hear from them again. And we never know what happened. Some of them we can figure out what went wrong, but many we don't. And the idea that we had in one of our motivating factors is to use the CubeSatSim and amateur radio to help builders. And we call this, with apologies to Neil Armstrong, one small step at a time. And the idea is most CubeSat teams at universities and high schools, they tend to go straight to building a flight model right away. And we think instead, before you run, you should start by crawling. And we believe that amateur radio and the amateur radio community and learning about radio just has huge, huge benefits. Then, when you're ready to walk, build or borrow the AMSAT CubeSatSim. So learn about a real CubeSat. And the CubeSatSim shows you every aspect of a CubeSat mission. And it also gives you experience building, troubleshooting, operating, learning, monitoring, all the things that you're going to need to do on your real CubeSat. And also, it's a great team building exercise to get your team together for fundraising, for all kinds of things. Then you're ready to run, build your engineering model or your test unit. And now you're really getting into getting ready. And then you're ready to fly in terms of your flight model and the way you go. And we're actually starting to see some CubeSat teams do this now, where they're starting out on a new project and they're starting with the CubeSatSim, which is very exciting. So there's two versions of the AMSAT CubeSatSim. The main one has 3 boards, as it's shown on the left. There's also a light board that just plugs into any Raspberry Pi, shown on the right. And you know, they're both only about $200, or the CubeSatSim Lite is even cheaper, and just requires basic soldering, except for a couple of surface mount components that we hope to make available. And when you build it up and put it in a 3D printed frame, you've really got something in your hands to show off. So in addition to the AMSAT CubeSatSim project, we've published everything on GitHub. We have papers. There's a wiki with step-by-step instructions. And we really want people to build them. And a lot of people have built them and had a lot of fun and used them in classrooms that we'll talk about. But AMSAT also has a bunch of loaners, too, that we've been making available in ruggedized cases, shipping to schools and events. And this has been very, very successful in terms of demonstrations and getting the word out there and showing people, you know, what a satellite is and what it's all about. Now, in terms of the ground station, there's a bunch of different options, and ground stations for a real CubeSat are quite involved, you know, rotators and high gain antennas and that sort of thing. But for the simulator, it can just be a PC with a little RTL SDR dongle that only costs $20 and then free software. Or you can do it on a Raspberry Pi, again, with free software. So there's all kinds of great opportunities. So just briefly, these are some cases where we've used the CubeSatSim at universities and high schools. And you know, people have used it for all different purposes, for demonstrations or as a design exercise or as a soldering and installing software exercise. We've had some really good feedback on that. And thank you to all the professors and teachers that have taken it into their classroom and provided us with feedback. So the one last topic I want to talk about are payload sensors. This is something I'm really excited about that's in the latest version. So in addition to the Raspberry Pi and the main satellite, the STEM payload board has a microcontroller, such as a SparkFun Pro Micro or an STM32, which you then program in using the Arduino IDE for, you know, simple sketch programming. And it's got a couple of really useful sensors built in, this temperature, humidity, pressure one, and also a 3-axis accelerometer and gyro. And in addition, there's this prototyping area where you can add your own sensors as well. And we're really excited about what people are going to do with this in terms of adding their own capabilities. So if you're interested in learning more, if you go to CubeSatSim.org, there's links to all the different places, including these two recent articles that will give you a lot of good details and background. And of course, feel free to reach out to me. So in summary, CubeSats are a great tool for space and science education. And the CubeSat Sim is just a really low cost, low barrier to entry way to get some good experience. And we think it will be useful for teams building real CubeSats, for people designing and building real sensors. And in the future, some of the things we're working on, we're hoping to have kits soon available through AMSAT.org and also classroom activities. But for now, you can get these cool remove before flight keychains from AMSAT if you follow that link there. So anyway, just want to thank all the contributors to this project and also acknowledge all the open source hardware and software that makes this possible. So thank you very much.